Here we go. Welcome to Code Hangout number 131. Today we're going to look into analyzing the replay data. Here we go. And I'm hearing myself. To Code Hangout number 100. Perfect. Yep. So I've been away for 2 weeks. Partially because I was away from streamable equipment and partially because I was just sick as a dog. So that's a tradition that I have done 2 Christmases in a row now, and I hope it will stop there. How is everybody? How is 2024 treating you so far? Today we are going to look at analyzing some replay data for some scientific research. So I've done some temporary kind of experimental data collection, and I have a little script that kind of pulls the data and kind of just parses the replays and so on, so I can kind of do something useful with them. Let me just see. So, for example, here we have 500 replays that have been collected so far. Actually, let's see. This is on the server. We have 1,000 replays. Okay, so this script... Oh, yeah, I disabled that. All right, that's going to take a little longer. So we have 1,000 replays to play with. That's from 2 days gas and last night's Simon puzzle. And we should now have these replays here. 1,020 of them. Excellent. And they should be in these JSON files that I can open up. And they are a bit chunky. All right. And let us do this. 1 second. I had some code here earlier. That was... Okay, that's just generating these files. Load test data. Test data. And oh, okay. This stuff I can do here now, right? Yes, yes. So TMM stands for total, min, and max, and it's just had a little help of stuff here. Let's go put these here. And instead of writing them out... Oh, instead of actually doing this... So, one second. So so load test data basically reads in all these files, and then it parses them and generates JSON, and then that gets written out. So now I want to do... Instead, we're not going to call this process data set. We're going to call this compile data set, because we're taking the individual data files and we're compiling them into a usable data set. And now the process data set will do something like that. Or actually, we'll just do that data set, right? And then we'll do something like... We'll do process data set, and we'll do await fsp.read file that, and we'll do the json.parse that, and the puzzle ID will start. We'll for now we'll look at the actually. I was gonna. We'll look at both, but I think the Simon puzzle probably has more. So we'll do this one first, because it'll be slightly faster. Let's see, is Mark in here? Hey Mark, how you doing? You have a new keyboard. Yeah, I bought a mechanical keyboard a while ago with RGB and all this stuff, and you know what? I used to obviously have the Model M and all this, but I've gotten so used to these low profile ones. So maybe a half-height mechanical I need to try sometime. I'd love to get into it. Like, I deserve a better keyboard, but man, I've been using the same K270 Logitechs for like 20 years now, and I've kind of just so used to them. Like, I know what the keys are, I know how they react, even though they're like wobbly and it's cheap as all hell, you know. Hey, Missing Deck. How are you doing? All right, so we're gonna load in this file, we're gonna parse it, and then we're just gonna check that this file actually is what it says it is, right? No. because we are in the wrong place here. We need to do this. Like that. Actually, you know what? I'm just going to pass in pos ID. And then we're going to do that. Let data set equals, actually, it's going to be a const. And we'll just put the pos ID in here. Like that. And then we'll put that here. Oh, and my phone is charged. It's complaining. Unplug, unplug. Ooh, and I'm pressing buttons on the keyboard. Here we go. Can your mechanical keyboard do that? Press its own buttons? We can get rid of this. And that. And over here we probably something isn't quite right. Oh, no, 652. And if we do the other one, it's 368. Okay. Excuse me. So I was actually wrong. So the gas... So that's interesting, because normally I think Simon's puzzle has more traffic on it. But I'm guessing the gas is easier to solve, so people solve it more often. Or it could also be that the Simon's puzzle just was released earlier, right? So let's refresh. This is today's analytics, right? So if we look at Simon's puzzle here, that's the graph for Simon's puzzle. Okay, let's imagine we can remember that. And now we'll go to the gas one, which is P4 something something. And it's actually no longer in the top 10 or whatever that is. Probably there's a new gas now. Oh, no, here it is. Okay, I was wrong. Yeah, because that was released later, and obviously my data collection only started, you know, a couple hours ago. So, interesting, in that time, fewer solves happened. Oh, let's actually limit this to just solve puzzles as well. So if we're looking at solves here, around 100 to 120 per hour. And on Simon's puzzle, in the last couple hours, just under 60, 70, 80, 90. So less, right? So that's interesting. I mean, this is all stuff I want to do. I want to get the data of this curve, and then align all the puzzles to the same point to see the shape of the graphs, right? Rather than the relativeness in time. Okay, so let us we'll actually do this something like that. And we'll work with this one for now, just because it's shorter, although both of them seem to run fine, just until this code works. So what I'm going to do is I'm going to look at the actions and the time. I'm going to just loop through the data like that off data set. And I think that's all we really need, right? Right? And we can, I guess we can just do it for both. Thankfully, programming code is fast enough to do this sort of thing. And this is probably super tiny. So let's make it even smaller. No, I'm kidding. We'll make it bigger. Here we go. So from this, I can see that for this first test puzzle, we have a total of 716,000 actions, an average of 1,946 actions per puzzle. The maximum number of actions taken to solve a puzzle was 9,500, and the minimum was 242. Now, this stuff alone would be nice to put in a histogram, right? And I might have to do that. We'll see. You know what? Putting that on a histogram wouldn't be very difficult, right? What do we need for a histogram? We just need the numbers, right? So we need some CSV. We need to convert this to CSV. So really, all we gotta do to convert this to CSV is, and then we'll probably need to save it to a file, right? But we basically want to map this. We wanna do, and in fact, let us do a load data set, and that basically just does this, right? Boom, load data set. Because we might want to reuse that. Okay, so forget this for a sec. We'll do something like console.log, and we'll just do dataset.slice. So I'm just gonna take a couple rows to align my head. I was doing some CSV conversion stuff for the plausible data just to import it into Google Sheets. So for each row, we need to map it to, we need to get these kind of bits of data here. Oh, I'm still annoyed that we have to surround these with round braces here. And we want to convert them to a different object like this. I'm just trying to think what we need. A column of, we need durations, we don't need time, and we need the action count, right? So we need actions. So we can do, say, duration, replay duration, and actions, we can do replay.actions.length. And then we can run that through my little CSV function, which I think I have in here somewhere. Here, this thing. Well, I'll just stick it up there with the helpers. Boom. Man, don't look at this code. This code is not for human eyes. So if I do this and I run it, data set.slice. It will run once I have the right syntax, right? And if I convert this to CSV with this little helper function, it should get a nice column header up here with tab separation, all that stuff, right? And then we can, do I want to, duration. So duration is in milliseconds. So we probably want to normalize that to seconds. So we can just divide this by 1,000. And I think rounding to seconds is reasonable for this. And I think I actually want to include the name of the data set here. So how does that work? We'll do this. We'll do puz ID duration, and we'll make that short because it's got to fit into a column header kind of thing, right? And we'll do the same thing down here, like that. And this will be acts. Just act. Will that work? Yeah. So that'll work. And then we'll actually want to push that into a file, right? So we'll do await fsp.write file. We'll do all of this. Write file. CSV. Replay. Restore. Fuzz and then we'll just put this in here, I believe. And we, like, if we do that and run that, we should get 2 CSV files, and they should look like this. And then we'll rerun it with the full data set without the slice here. In fact, we'll keep the slice around for future reference. So now these are big, and now if I go into my Google Sheet here, somewhere I have a giant Google Sheet, not that one. Yes. Oh yeah, my computer doesn't like open these anymore. Statistical analysis plausible. All right. So I might have to create a new spreadsheet because it really doesn't like me putting so much stuff in here. Some of these are very large data sets for a web-based spreadsheet. right? And if I just do this and then say insert chart, and I'll say histogram. I love histograms. Is that a histogram? Histograms. And then I'll say we've got these 4 data sets. So just to remind ourselves, actions are counts of actions, right? Excuse me. And duration is the duration of a solve in seconds. And we might want to group them differently. Yeah, let's group them separately. So what we're gonna do is we're gonna do the durations and the actions separately. So let's do these 2 first. Insert chart. So that's just durations. We'll change it to histogram. We'll do no labels, right? And then we'll probably want to use a log. We want to get outlier percentiles, bucket size automatic, and the vertical axis, we want to do it logarithmic, I think. I don't know. If we only had a mathematician to advise us, that would be awesome. Mathematicians are so cool. They know all these things and numbers and such. All right. Okay. That looks odd. I'm gonna get rid of that item dividers because it's creating these weird gaps at the bottom. I don't know why that is. And the buckets seem relatively large. Huh. Okay, actually I don't like the logarithmic vertical axis. I did a logarithmic analysis with data from... Is that the same data? 1 second. Yeah, I guess I did the log of the time and the actions as well. So wait a second. Here the vertical axis is logarithmic. 1 second. It could also be that because these 2 puzzles are very different, putting them in the same kind of thing on the same chart might be a bit tricky. Yeah, I wish I could get rid of that overly wideness. Yeah, I think by using the log of these, we're actually scaling the x-axis here. So if I take these, give myself a bit of breathing space, stick them over here. This is the actions. We'll do that in a minute. So if I do this and I call this log, so we'll call this log of duration, right? And we'll say this is equals to the natural logarithm of this, and we pull it down, right? I have an itch in my nose. Excuse me. I'm still not 100% well. My nose is still being a little bit of a pita. All right. And then I should be able to just do that, right? And then if I do this, so that is log B2, B3, etc. And if I now change this to use those instead, so A, B, so if I go just to E, right? Then I should be able to just add log and log. And any mathematician that disagrees with my willy-nilly usage of logarithms, speak up now, or forever hold your peace. All right. Hey, that looks more like it. This is what I was looking for. Normal distributions. Well, they're not symmetric, so I guess they're technically not normal distributions. What are they? Some kind of distribution, right? All right. If I make the buckets tiny. What? Ah, because they're logs now, so the buckets need to be smaller than 1. Like that. So if I can make them tiny, we'll get that. And the vertical axis is not logarithmic, doesn't need to be logarithmic. Okay, yeah, that was throwing me off. All right, let's make these automatic. Okay, so this compares our the logs of the times. And let's do the same thing for... actually, you know what? I'm gonna take this. Sorry, I'm a sucker for having formatted... for formatting my spreadsheets. I am a sucker for it, I tell you. If I make this high, and I make these... didn't I tell them to do that? Boom, here we go. Oh, no. No. We'll do this. We'll make them like these. Nope. Like this. Yes. Okay. And now we're gonna do the same thing for the actions. I think we should also do logs then. So let's take these two, put them there. Write log of actions here and here. Log of actions here and here, and then this is just going to be log of this. Yes, and this is log of this. And autofill, right. So now we're just gonna take this. Nope, not that. Can I just copy paste? Yes, I can. We're gonna take this, and now we're gonna add... this should go to H. And then we're gonna add this, and we're gonna remove this and this. Sweet. All right. So, and then we're going to take a moment to ponder what we're looking at, because sometimes you gotta stop and sniff the math. Here we go. Am I in the way? Can I just do that? Yeah, I'm just gonna move it over. All right, so this is the normal distribution of, in blue, of Simon's puzzle from last night in blue. And this is the duration, the amount of time the solve took. Does that make sense? Why the no, sorry. Yeah, these are the bucket size. Oh, yeah, we can normalize the bucket sizes. Because right now the problem is... yeah, how do you normalize vertically? Density plot might also work here. Density plot. Ooh, that sounds exciting. What's a density plot? Density plot. Mr. Grog90, are you a person of a mathematical persuasion? Density plot. Is that something that this spreadsheet knows about? Density plot. What is a density plot? Density plot. Definition. Density plot is the representation of the user calculate. Density plot, Google Sheets. How to make a histogram in Google Sheets? No, but density graphing on Google Spreadsheets. Is that it? Ooh, that sounds... this looks like homework. Histogram on Google Sheets. Overlay a normal distribution curve. What is a histogram? How is a density plot different from a histogram? Speaking of which, I think we can add a series. Can we add a distribution curve? Chart style, histogram, chart next title, series, line thickness, line dash. Name the range, distribution curve. Some of these are probably just for Excel. Smooth. Yeah, this looks normal. This looks like it's not Google Sheets. It says spreadsheets. I'm guessing this is using Excel. No, it says Google Sheets. Wait a second. Norm dist, which calculates the value of normal distribution. Normal distribution. Let's see normal distribution curve looks like with this data. Insert chart and select line chart. Okay. Wait a second. Line chart. And then line chart, and then make it smooth. Line chart, customize chart style, smooth. Okay. But I think we probably need to do that first. We need to do our own histogram data, right? Okay, I've done this before. All right, well, this is a smooth line curve and calculate slightly different. Sorry, I don't know what that works with Google Sheets. Yeah, I think you basically gotta get the histogram columns you basically got to calculate these buckets yourself. But before we do that, one thing I would like to try to remember is how to normalize the height of the buckets, right? Because it would be nice to just vertically scale these to be on the same scale. And right now, primitively, the only thing I can think of is to literally remove the buckets, but like remove them in a sort of like align the number of samples, right? So what we could do is we could say, we could synthesize new samples, right? Ooh. So basically we could say, okay, one of these has more samples than the other. So this one has 653, right? And then this has 369. So what we could do is we could scale this, like we either randomly remove a number of samples from here with a random distribution to match them up, or we randomly duplicate samples here in a way that doesn't affect the normal distribution. Or we graph, or we do, okay, that's a, because if we graph them ourselves, we can scale the graphs, right? So let's do this for a sec here. All right, so I'm gonna put this aside. I'm gonna just take this as a reference. And basically what this does is, we calculate the distribution elements, you know, the median, the mode, and all this stuff independently ourselves. And then, okay, so we're gonna need some space. So we're gonna insert 1 row above, we're gonna insert 2 rows above, insert 3 rows above, and then we're gonna do that, right? So we need, we're gonna do this on the duration, and instead of the log, we'll do it on these for a sec here. So, actually what we're gonna do also, we're gonna add 1 to the left here. So we'll do AVG equals average of, and we are in B8B, something like that, right? So we need average, median. All right, so we'll average, we'll do median, B8, B, boom, right? Yeah, no, if we'll do this and this. So I take the, oh, no, if I take this and put that here, and then we'll change it from median to mode. Average, median, mode, median mode. And if I drag this over now, will that work correctly? C8, yeah. And then the final one is std dev. And we'll have std evp. And, oops, actually take this. Well, we'll do that. std evp, boom. Like that. And then we should be able to just take these, drag them over. Right? My microphone is crackling. I think my microphone is mechanically in a little bit of trouble. Hey, Shelby, how are you doing? Okay, so we have these 4 numbers now for these 2 columns. Create the frequency bins. Okay, well, I think we're going to need some space. Insert 1 to the left. And I'm a bit concerned because it seems to want more. Okay. All right, we'll insert another one, and we'll insert another one. So, and we'll insert another one. So, we'll do the bins here. So the bins are going to be, name the range of bins. So we need to do our own bins, right? So we have, how many numbers do we have of these? We said 300, not some, give me the count. Min max count, 368. So shall we do 10 bins or 20? Shall we do 20 bins? All right, let's do 20 bins. 5, 10. And I'm gonna just delete this for now. Right, and if I do this and go all the way down to here, we got the bins, right? Can we do this and that as well? And yeah, that's fine. And now norm dist. So this is going to be norm dist f2. So now I'm gonna translate this to my own coordination here. So that's our bin number. The mean is D1. So the mean is average. So that's our mean. Then the standard deviation is D4. Boom. And then finally, it wants us to put false as the cumulative. Okay. False. Boom. It wants to autofill past the last bin. Formula column. Basically, I'm looking at this, and of course, he's only created bins to 100. What I don't understand is F2. What I don't understand is this is gonna be okay, yeah, okay. I gotta pin these down. Okay, so now I can pull it down. The thing is, this is gonna look at only... Oh. Wait a second, but it doesn't use the data at all. Oh, okay, wait a second. The problem with that is it doesn't actually use my data. It just gives me the normal distribution that corresponds to my data, which isn't really what I need. Can I build a histogram the same way? Okay, first of all, I'm gonna change this to be what they call it, median. The mean. Normal distribution, yada yada yada, frequency for. As we're going to create a totally new chart with histogram and normal curve overlaid, easier than modifying this one. You can put this normal distribution chart to one side now or delete it. Okay, frequency distribution, blah blah blah. So array formula, frequency formula, assign our 1000 scores to the frequency bins. Okay, so we are doing that here as well. Okay, cool. Histogram. So now this is going to be array formula of frequency of scores. He labeled them scores. So scores would just be B8 column B, and bins would be D8 column D. Doom boom. Wait a second. 1000 scores to the frequency bins. So now the bins are, the numbers are the sizes. Okay, wait a second. Okay, I think what I've got wrong here is the bins need to actually fit the values, right? So let us also do min and max. We'll do, and this will be min, and this will be max. Right, so our bins actually need to reach up to that value, right? So 20, let's call it 30,000 divided by 20. 30,000 divided by 20. 30,000 divided by 20. Nope. 30,000 divided by 20 is 1,500. So this should be 1500,300. And then we should be able to pull these down to here. And we can probably cut all of this stuff off. Now, I wish this would be automatic. Okay, can I do it the reverse? Can I do, one second, insert one above, bin size, boom. If I make the bin size 1000, so we'll do equals this plus this. And then I can just do that. This. Boom. And then I can just change this to whatever I want. Like that. And the histogram the frequency formula goes to 1 bigger. Which I find slightly weird. Why does that go to 1 further than what I have here? There's nothing in here. This goes from there, D9 to D29, B9 to B whatever. It's still... Okay, maybe that's just the overflow. Maybe that's everything that doesn't fit in the existing bins. Okay, but now I think I can see where they're coming from. Scale the normal distribution curve so that you'll show on the same scale as the histogram. Since we have 1000 values in bins of 5, our scale factor is 5000, meaning that I multiply the normal distribution values by 5000. G2, normal distribution, norm dist. All right. So histogram 2. So if histogram. Pro tip, you can cross copy I1, I2 into J1, J2. You'll fill the column with values. Copy values. Copy the column frequency values into the adjacent column J. We need this for our chart. This column of frequency values. Scale the... Why do we need a copy? Can I avoid that? It wants these twice. Insert chart, select combo chart. Because I'm wondering, can I make my life easier by just swapping these around? I'll put that there, and then I'll say insert one to the left, and we'll say normal distribution, and then we'll say this is basically just... now the scale of 5000 from the example, where'd they get that from? Where did they get that from? Since we have 1000 values in bins of 5. So it's the number of values, total number of values. So it's basically the count here. So bin size. Set one above. What if I call this count? And then equals count. B dollar. Or B10 colon B. So count C B. So if I do this and then drag it over and drag these over, get rid of that, drag that over. Okay. So he took the bin size, multiplied it by the total. So 800 times that would be our scaling factor. And then that gets him these numbers, which are a lot larger than these numbers. All right. Insert. Okay, so this is going to be this value multiplied by this value multiplied by this value. And I'm gonna have to rig these up. This is gonna be a pain in the ass to do more than once. Let's hope it's all worth it. Okay, I think we're ready. Insert chart, combo chart. All right, so we should do this. These are the bits of data. What's the histogram 2 for? Histogram 2. Use F as labels. F as labels. Sure. Left vertical. Histogram 1, histogram 2. What is he using the histogram 2 for? Histogram 2. I think it's literally using it for... He's using it for styling. So, yeah, to make a histogram group. Why is that literally just to merge the bars together? Okay, we probably don't need that. All right, so if we'll do an insert, no, insert chart, and it'll be a combo chart. And what do we need to do? So, a bunch of stuff. So our normal distribution is on the wrong scale. Use column E as labels. We should have, yeah, E as labels. Okay, so that's our normal distribution. So then we'll want to do customize, chart style, smooth. Okay. Customize, axis, chart axis, chart title axis, left vertical, min max, major. So vertical axis. Yeah, this is, I hate, man, this stuff changed so much. This is not what it looks like anymore. I remember there's a way of doing left, right separately, but I don't know if I have to enable that somewhere. Vertical axis, scale factor. Is that why we need two different ones? Min, max, major. Normal distribution. Histogram. Wait a second. Wouldn't the normal distribution be the line, not the bars? Ah, yeah, no, he swapped them here. So we want the normal distribution. wait, okay. How do I configure that? Delete the axis and set it to select the vertical axis. Select option F as okay. Chart type. So we need to tell it which is which. Insert chart, combo chart. So the bins are our labels. Remove the title and legend selection smooth option. Smooth. Delete title and label. Okay, we don't care about that for a sec here. Chart title and axis title. Vertical axis title. Vertical axis, horizontal axis title. Chart subtitle, chart title. Okay, no, don't care about those. Column. Line 2. Why do they not have... why are they called line 2? Why are they not called... Ah, here we go. Okay, so normal distribution, that should be the line. Right? How do I tell it which one is the line? How do I tell it which is the line and which is the bar chart? How do I tell it which is which? Series, normal distribution histogram. Yeah, I think, wait, here he's still got it the wrong way around. How did he swap that? Customization type. No, select the series action, series type. Ah, here we go. Columns. And then normal distribution line. All right. Okay. Slowly. And for the delete the axis name. So Select the vertical axis. Select smooth option. Select the vertical axis. Here. Delete the axis name. Minimum value. I think the auto here is fine. Grid lines major. Is that important? Scale factor default. Grid lines. I think they care a lot about having it visually look right. Now, what I don't like about it is that the blue line is just the normal distribution. It's not the actual distribution that we actually have here. And is 20, are 20 buckets enough? Or do we want to go with like 50? Now, what did I want to do before? I wanted to have the two charts on the same thing. Okay, so the question is now, can we repeat all of this shenanigans? Ooh. Can we repeat all that shenanigans with a second column of data? So right now, this data is kind of in the way, right? So the question is, can we copy all of this over here? It fits. Okay, and now what do I need to do to make it work? So this now, instead of being I, it needs to be G. Like that. And then instead of being B2, it needs to be B2, G2, G. Boom. Right? And then these, are these all correct? No. So B becomes G. And H10 is still H10. Okay. And then this one is that, and that. And that looks okay. But do we want to change the bin sizes here? Yes. No. Other way, other direction. Is there some... Wait. Normal distribution. Oh, wait. This one isn't correct. No. Wait, that's correct. G10. G12. Okay. Is it just this we have to change? Why do we still have everything in this bucket? Oh, wait. This isn't right. G. Okay, so I think we needed to go the other way. Yeah. Okay. And in fact, if we modify this now, like that, we can scale it and shift it over a bit, like that. So now the question becomes, can we add all that other data in there as well, right? So now the question is, can we add another range that's basically this? Okay. And then we want to add a series. We don't need, well, bins, We probably need to add the second normal distribution. And we want to add the second histogram. And this normal distribution looks very strange. This looks very strange. And this, is this all correct? They look to be correct. This first label, I don't think I got that right. That looks wrong. So the normal distribution, the first argument is supposed to be... Okay, this wasn't really what I wanted to do in this stream. I wanted something more exciting. But man, I'd love to learn these techniques. And once you know them, you know, you can just use them a lot. They're kind of useful. Oh, my nose. F2. Like here. I don't understand. Drag it all the way down to G22 to fill the whole norm dist formula. G22. But it references F2. Oh, wait. The F2 is the bin. Ugh, I'm an idiot. Okay. All right. Let's see if we can fix that. So the F, this should be the bins. So it shouldn't be G10. It should be I10. Right? And then here, D10 is the bins. Right. So here, the bins need to be even smaller. Yeah, okay, here we go. Excuse me. So now, one of these lines is the wrong color, or is the wrong kind. So we need normal histogram green needs to be columns. Okay, and now this is where we should be able to scale. Right? Format, columns, histogram. So in... okay, so green histogram goes with a yellow trend line. I don't actually know. Let's make this more useful. This is gonna be 2, and this is gonna be 2. And maybe I can just color match them. I think it's okay to reuse the same color here. So normal distribution 1. So if that's 1, then histogram 1 will also be... Why does it give me this here? Fill color blue. Okay, and the normal distribution 2 is yellow. Let's make it red. And then histogram 2 is also going to be red. Maybe not that red. Maybe it's red. All right. 1 second, guys. Hey, TTVT star. That's a lot of extra T's. All right. Okay, so the whole reason I'm doing this is so we can scale it vertically. And I think we did the scaling in here, didn't we? Ah, but we scaled... What did we scale? We scaled the normal distribution. And we kind of auto-scaled it. But we kind of want to scale the histogram too, right? So we either scale it here, but I think there's a scaling factor in here somewhere. I thought I saw it earlier. So, series, histogram 2, columns, left axis, right axis. So we kind of want to include the second set of bins. Actually, no, these numbers aren't the bins. These are the counts, right? By giving it the separate axis, it can automatically rescale. Okay, so normal distribution 2 should also be right axis now. Did I get that wrong? Left axis, left axis. So, yeah, I don't know why these guys are scaled lower. So maybe my scaling factor here isn't quite accurate. So if I say times 2 and then drag it down, yeah, it seems like it was half of what it should have been. Not sure why that would be the case. Now this is all kind of clunky because I can't easily, replicate this. But this at least is a model of what I could do if I write my own code to set it up, right? Because this is only useful if you can do a lot of them and compare, you know, many of them. But basically, I guess this gives us a comparison of the normal distribution of these two puzzles. And I'm kind of interested in comparing shapes, because if you're scaling everything to match, you're obviously not comparing exactly where things are, right? So now the other question is, if I change the bins, if I match up the bins, for example, like if I do this, wait, am I using the max anywhere? Trying to remember. What's the thing that moves it? Well, these are the bins, right? So then this would be it. So let's say we put them both into bins of 100. Yeah, then they won't even overlap, right? And if we put them at 1,000, we kind of get to this situation. So this is kind of where you want to take the log, really. So let's see. If I insert one to the left here, and then I'll take this and I'll copy it over here. Don't need these for a sec, right? And then if I do this equals log of that, and then we'll just take all of this, delete it, and then do that. And then this stuff, does that not work anymore? This stuff, does that not work anymore? Why can't it take the average? Is 0. Wait, what? Function log, parameter 1, value is 0, should be greater than 0. Do I have negative values in here? Oh. Yeah, the 0 should not happen, so we should be able to just remove that. Okay. Now these are all zeros. Why? Is it because these are too big now? They need to be like fractional? Ah. Kind of like that. Uh, 0.001. 0.0001. And the histogram data. One. 0.5. 0.75. 0.25. Here we go. Okay. So, this is kind of what we had before, but now we have the ability to put them both on the same thing. But this is super clanky. Are you on the CTC fan Discord? That's kind of the easiest way of contacting me. All right, this is, it's not going, this is gonna take a while to get me anywhere useful. And it's not really what I wanted to do in the stream today. So let's put that aside for a moment. What I really want to do is actually try to create a heat map. So what we have with the replay data is information about where people, quote unquote, spend time, right? And let us refresh the data set again and see how big that gets. Ciao, guys. See you later. So 1,153. Okay. There are now 13 megabytes of JSON data. So now the idea is, basically, how I imagine a heat map to work is basically I'll just create a sort of a canvas over this, and then I basically paint a round circular sphere once for each time that a user acted in that location, right? And not necessarily one user, but many users. And then over time, we'll get a heat map and we'll see, okay, you know, I mean, I don't know, it might just average out to everything because obviously the board gets filled, but I think it might be interesting for the pencil marks. And it might actually, you know, when a single digit being placed is actually a weak heat signature, but a digit being placed and removed and placed multiple times. The more I think about it, for the digits is actually not really very interesting. I think it's mostly interesting for the pencil marks. When you say density, is it still just a line graph, or are we talking something like a heat map? That's kind of the question I have. Well, you can ask, the best thing is to ask in the SudokuPad feedback channel. Because then, you know, if it's something that somebody else can help with, they can chime in, and that's where I kind of do all my Q&A regarding SudokuPad. Densities are kind of... Let me... Okay, I'll give it one more Google. Density... What do you call it? The... Density plot. Density plot. Is that the name? I mean, everything I'm reading refers back to a histogram. Like, I don't see anything called a density plot anywhere in Google. Oh, maybe this? Ah, but that's a histogram, no? That's just a histogram. How is it different than a histogram? In the meantime, I'm gonna work on this. So what I'm gonna do is, and the way I work on this sort of stuff is basically I just cut and paste a bunch of code like this. It's a little primitive, but I like it. So what we're gonna do is we're gonna need a canvas. Canvas equals document.create element canvas. Then we'll do object. We'll just do canvas.width equals. And if we'll do. If we'll do this framework dot app.svg renderer dot svg element dot get vbox. That should get us the bounding box, right? So let bb equals this equals bb.width height. We're just gonna put that in here because there's gonna be a lot more stuff. This is just a little more compact. All right. No, I don't like it. I'm gonna do that. You will see why soon. So what's next? Object.assign canvas.style. And we'll do this position absolute. And the bounding box doesn't give us that. So that's actually not the function I wanted to use. I have a little function that I'm using in the code itself. Let's just use that. Dot get client. Oh, no, rect. Find bounds. Board bounds. Get content bounds. Here we go. If I do this instead of that, It doesn't give me the left, right, and top positions either. That is interesting. Why not? Dot style dot or dot client top. Yeah, I mean, content bounds I understand, but dot because the SVG element is obviously not there. JavaScript get position of item on page. Oh, my head keeps clicking with like analog noise in my microphone. Get the bounding client rect. So if I do dot get bounding client rect, maybe that's what I actually want. Maybe that's what I want, because so if I do bounds, because I want it in relative to like screen space, I don't want it transformed and whatnot. So if we'll do this, bounds, right, and then we'll do left, bounds dot x, and we'll do it math dot round. Round x px that left, and we'll do top y, and we'll do outline 10 px dashed magenta, and I'm just putting that there to check that this thing actually worked. Oh, and we'll do document dot body dot append this. Boom. Or is it append child? Dot append. Is that the one we want? No, it'll work. And there's a again. Stop it. Unexpected token. Yep. I think it'll be in there somewhere. Okay. So if I do document.query selector all canvas, and then if I do this, dot for each dot remove. That should make sure we're just wiping it out before we continue with the next item. Here we go. And now we should be free to draw onto this. Trying to remember last time I did something like this. Do I want to draw my own pixels, or do I want to... I think I can do a circular gradient. Canvas circular gradient. I'm sure I've done like... I think I might be better off having some sort of bitmap. I'm just gonna... Oh no, this should work. This should work. Create a radial gradient, right? Radiant gradient. Okay, can I just change that here? So instead of pink, white, and green, what if we... Can I not edit this? I don't feel like I can edit this. Oh no. There's just no cursor. Wow, okay. This is weird. Alright, so x1 inner circle is at Create jeez. Fill the circle, draw a rectangle. So it's 20, 20, 160, 160. So we'll draw it from 0. We'll draw it from, gosh, 0. Oh, I think I see the cursor finally. To 100, 100. And then this goes 100 here. Actually, it'll go 50 here. 50. Create radiant. 50. 50. 50. No? What are the arguments? I should have paid more attention. X1 radius. 50, 50. So XY 50, 50 radius 50. XY 50, 50 radius 50. That looks like it should be concentric. Oh, I need a small radius for the inner one. So if I do this. So then it goes from inner red. So if I put this at white. Oops. This as white. And this also is white. Or can I do this transparent? So if I do hash FFF 0, probably it wants that as a string. Okay. Hash FFF 0, that should be transparent white. And then this should be 0, hash 0001. No, F. This should be black opaque. And this I should be able to draw, you know, whenever. Now the fill rect, I don't really need that, right? No, I do need it. Okay, interesting. Do I need the third color here? Probably not. Okay. Okay. I should be able to just take that and use it. And we can just add that to our little thing here up top. Like that. And then we'll do a const draw blob. And it's gonna be X, Y, size, right? And it's basically gonna be this. And now we gotta translate this X, Y, and size to this stuff, right? So, so these are just gonna be X and Y. X and Y. X and Y. And size over 2. Right? And then this will be X minus size over minus 0.5 times size. And same with Y. And then we'll just add over here. X plus Y plus. And then we should be able to just draw these kind of blobs. So if I now do something like draw blob 150, 150 of size 40 or size 80, let's say. We get a little blob there, right? And if I draw a second one that's a little bit over, we'll get this. Okay, so this doesn't really do additive yet. Right? No, it does not. it'll just fill it in, right? But what we want is additive. So we can do this with blend modes, right? JavaScript, canvas, draw, additive. Set blend mode for drawing strokes. Additive heat map. You know what? I'm actually gonna have a look at CodePen and just Google heat map. So we should be able to just do canvas heat map. Basically what I need is I don't want two things to draw and to be the same. Okay, wait a second. If I do it with partial transparency instead of full opacity, right? So if I do this as 2, and then I'll just do for let x equals 0, x smaller than 200. Let's just do it from 100 to 200, x plus plus. We'll just do this, x, y, 80, right? And that should kind of do that. Does it? No, it doesn't. It doesn't add together. No, it should. It should add together. X, Y. What if I go down a little bit and here do plus equals 10? Yeah, it's fine. Fainter. No, this will do the trick. It's weird though that it doesn't. If I just do this on the same spot. Yeah, you see, it doesn't get darker than this. It does at the end. Okay, it's because the outer side of the circle overrides the inner. No, wait a second. If this is both black, then because it goes from black to white, but I want you to go black to. Oh, okay. This is what we want. Yes. We want the same color, but different opacities, right? And now we can go, let's say, from red to blue as well. Although that won't really work. Okay, so we'll want something like red. So if I'll do red instead of black. All right, and then we'll make it very faint. We'll make it a 1 here on the opacity. And we can actually go fainter than that if we go double digits. And we probably want to do that just for better control anyways. Right, and then here, it'll be 0, 0, and it'll be 0, 1. Like this would be super faint, for example. And then obviously we have a problem with resolution. But maybe something like 16. Okay. So now, we need to draw these blobs according to the data where it goes. One of the issues is that the position of center marks and corner marks. So in the moment, like, I cannot really draw. I mean, I could make up my own thing, right? So I could say, okay, upper left corner is just corner marking of 1. And we could do that quickly just to see what it looks like. I wonder if just drawing the values, because if I just draw where digits are entered, odds are not insignificant that every digit gets entered exactly once. Now, in practice, I'm sure there'll be some undos, but that's not really the only thing we care about, right? We kind of care about attention. The other thing we could do is we could just say every time we could do a heat map of just selections as well. All right, so let's get the data in here. Let's get in here, right? Let me just copy that over here. Yes. We'll start with the smaller data set because it's already chunky enough. And what was the code to load? Process set, load set. Here we go. Here we go. So have a little function up here. And I use load set to do this. Okay. So load set, and the smaller one is this one. This one. All right. We'll do this. Just see, you know, does this take a long time? Load set. Okay, so that's our data set. And then in here we have all the replays. So I think what I'm gonna do is I'm just gonna streamline this for a sec. We're gonna get rid of this for a sec here. We're gonna go through all of these. We're just gonna flatten it all out. We don't care which puzzle the action comes from, and we're just gonna look, let's say, at all the select actions, right? And we're just gonna mark those out, right? So we'll do set.map, and it's gonna be each one of those gonna have a replay in there. And what we really want is the actions, right? So replay, actions, and we're just going to return those like that, and we're going to flat map that. Just like Python. Somebody might say this looks like Python. All right, and that gets us 346,000 blah 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 actions. And then we're going to filter those. We're going to flat map that, and we're going to filter those. And in each by action a dot starts with SL colon, right? How many select actions do we have? 136,000. All right. And then after we filter that, we're going to map it again. And then we'll do a.match. So we should have SL colon. Then we should have one or more cell references, right? So we'll have something that's row digit, column digit. \D is digit, right? And then we'll have one or more of these. And we'll probably need to do this to get them all, right? And then we'll have slash, and then we'll have some other stuff. We don't care. So if I do this, what is that going to look like? Doesn't like it. Needs a second brace here, I believe. No. Backslash SL backslash D. One extra brace, I think that's the problem. Right? And then we'll just get, we'll just do this. And we'll get the second element. Boom, boom, boom. Okay. That'll get us all the select actions, and some of those are multi-select actions. Okay. At this point, we're going to change this to slice only the first one out, so we can do a bit of debugging. So that'll get us the first data set here. Ah, thank you. Very much appreciate that. Are you on? Sorry, I was not in the joined on the joined chat. I was somehow stuck on the YouTube chat. Hey, oopsie daisy, sorry. Sorry. And I didn't even post the message into the chat either. Sorry, I'm really rusty. Like 2 weeks not streaming, it's like you're starting over, you know? Okay, so after doing this match, we actually want to split these out. So we're gonna do a dot flat map, and we'll do dot split, and we basically want to split them out by these. Actually, what we want to do is match by. We want to match by this. Yeah. So if I take that, what do I get? We'll probably do a global match. I don't think we need to do this, actually. Can I just do this? So if I don't do this, we get these kind of guys, right? But if I look at specifically 125, right? So this gives me more. And if I do, if I just do a map instead of a flat map, what do I get? I get arrays, and some of those arrays will have, okay, so then doing a flat map gets me all the cell references of selections like that. So 165 of them, okay. And then we'll just for each on them. Actually, we'll do a map first, right? And we'll do a blah 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 rc.match r \d c \d like that. And then again, we'll make sure it's an array, and we'll get 1, 2, 3 out of there. And that should get us RC arrays, 1, 9, yada yada. And do I want to parse them here? Yes, I do. So that's n parse int n, and that should get us two-digit arrays like that. And now for that, we have row, column, and for that we now can draw blobs. We got to figure out exactly where we want to draw them. So, but trial and error is actually acceptable here. So row is x is column times 64, I guess. Row times 64. I don't think that's accurate. 64. I think I need to calculate exactly what that would be. But what do we get? All right, it's offset. Because the problem is it's scaled, right? So I'm not. Well, okay, we know we have half a cell of margin. And we have... Let's just output this here. Forget that I can just save this and run it. 580 by 580. Excuse me. Apologies. Still recovering from a little bit of a cold. So, I'm just trying to think. It's 580 by 580, so we can probably just divide that we can... I'm not sure if that's a quarter cell. It looks more like a quarter cell, right? So if we take that... Let's have a look at this. If I do canvas dot width, if I can take canvas dot width and then divide it by 9.5, what do we get? 61. And we'll do the same thing for height. And then the margins would be divided by canvas width divided by 9.5 times 0.25. And then this divided by 9.5, that's just a cell. Times 0.25. So the first value should be the margin. Okay. So let's do a draw blob RC. RC. Okay. And then we'll do a cell width. Const cell width equals this. Cell height equals that. Right? And this is going to be a draw blob. Just converts RC to XYs. RC. And we'll do draw blob R times CW. And we'll do 0.25 times CW plus. We'll do the same thing for width. For height. Whoops. And then height is row and width is column. And then we'll just do CW. So I should be able to just do drop up RC now. And then just RC. And we need it shifted by half. So 0 should be 0.5. Ah, but this is 1 based, right? I think these are 1 based. Let's just do that. I think these are based, not 0 based, they're 1 based. Yeah. Okay, so we actually need to subtract 0.5. So negative that. Is that what I'm looking for? Yeah. Yeah. Okay. All right. Can get rid of the outline. There we go. All right. And now, if we do it by all puzzles instead of just the one, it's probably too many. Yeah. Way too many. So I wonder if some sort of pre-processing would be more appropriate. Because otherwise the resolution just isn't there. Like, it's just gonna be noise. And I wonder if over a large enough sample, it just evens out, frankly. Yeah, what we can do then is, if we do it over everything, and then we kind of renormalize it, and then we can just draw, like we calculate basically the heat map up front, and then we just draw it in. We don't like generate it, if you know what I mean. So we can just do let hits equals array. Or what if we do this, right? And then we'll do, and we'll just do something like, for each. And then we'll just do, hits R dash C equals that or 0. And then we'll just do plus plus. Like if we do this, what do we get? We get counts for all of these, right? And then we'll do hmax. Hmax equals math.max hmax. And that should get us the scale. And then if we just divide them all by that, we should get our number for each one. Okay, so now we can do object.entries hits. Well, it can do just for const. And what do we have? We'll have RC hits or CNT. And then we can just do RC, CNT divided by Hmax. Does that make sense? So we should have 1 for each of the 81 cells with a fractional number between 0 and 1 for the density of the blob. And we don't even need to do density. We can just do, we can literally do size, right? And the size here is this. Okay, we'll do RC dot split dot map. Okay, and then we'll just do const RC equals this. Val equals this. And then instead of doing this, we fortunately we cannot do this first. But instead of this being the size, we can multiply this by val. So it scales from 0 to 1. And then we'll just make this FF. And what do we get? We get this. Now we could scale it for the minimum as well. So we can do hmin equals number dot max save integer. And then we can do kind of this, but with hmin. Min. And then we'll have hmax slash h or hmin hmax hmins comma hmax. Then hmin, for example, is it's literally 1. So there should no, that can't be it. Number max safe integer, is that not a large number? Yes. Hmin. Oh yeah, no, that doesn't work. Because okay, so we need to do it at the end. So we kind of have to go through these. And then we'll just do hits or CNT here. And not do it in the first pass. So hmin H-min. The minimum of H-min. Oh, 1538. Okay, so basically the idea is that 1538 should be 0, right? So we don't just divide it by this. We basically subtract first H-min. So we'll do this minus H-min. And then we divide it by H-max minus H-min. Which gives us still the range of 1 to 0, but now it's starting at actual 0, right? And that gets us sort of kind of where the focus is in terms of selections. And the interesting thing is the biggest, and that stands out immediately to me here, is that the focus seems to be mostly on the cells that don't have given digits. And that's actually interesting. I did not expect that. Okay, so I think for the purposes of demonstrating the principle, this is this is all I'll probably have time for today. Oop, I just want to select this. Let's do it for the other puzzle as well and see if the data shows anything interesting. Maybe it does. Who knows? So if we do it for this data set instead, or if I do get puzzle ID, I do this, yes, then this code is completely generic. And this, we don't need to do. That's just some prep stuff. Prep stuff. All right. Don't need that. So if I do this now over here, and let me just reset that. Okay, and here it's kind of the opposite actually, because this is where the puzzle starts. And then once you kind of figure out that initial focus, and the color is terrible. Red, what should I do? Red, should I use like a bright green? Red, green. If we do this, yes, and then just go crazy magenta. Let's go crazy magenta. I think magenta is FF00FF. Hey, Poochie. Welcome home. Hey, Poochie. Toby looks at me with accusing eyes because I'm not here to greet him. He doesn't like that. All right. And we'll do the same thing over here. All right. Oh, I see. I can't resize. Can I do that? Yes, I can. Do that. Okay. So, exhibited 1, I'm speculating that the givens actually are easily dealt with. And then most of the thinking and selecting and marking happens on the empty cells. While on this puzzle, it's almost reversed. It's where all the initial marking and thinking happens on the initial line, and then once it's figured out, the rest happens relatively quickly. So I'm actually satisfied with that. I mean, I wasn't looking into doing any particular research. It was more like I wanted to see if this research is A, possible, and B, would actually lead anything at all, right? And I feel it kind of does. And this is not even looking at anything beyond this. This is literally just looking at the selections, right? So obviously, by looking at pencil marks and stuff, you could get all sorts of data. You could slice it all sorts of different ways. So I'm very happy with this result, actually. And that's all I have time for, because I started so crazy late today. So hopefully, I'm looking to actually stream more often, because there's some exciting work I got to get working on, and I'd like to actually do more of it on stream. So maybe I'll try to stream again tomorrow, and it won't be in an America-friendly time, unfortunately, because I'm not in America, and the sun is still the boss. So I might actually stream earlier in European time, and you don't have to watch, but if you want to stop by, watch the channel for announcements. Or, subscribe here, and I will let you guys know. So, yeah, this is sort of my first steps into analyzing the replay data, which I've been sort of talking about for years. and this data exists out there. I've literally just added some code today to collect some samples just today for these 2 puzzles, and that's it. But I would love to have a more robust actual data collection system in place for this replay data. In the meantime, this is it for today. Thanks for hanging out. And I don't know if I should do the other streams as code hangouts. If I should have a different channel for it. Probably not. I don't have enough viewers. If I should just have a different, set of thumbnails, different playlists, and so on and so forth. Or just keep doing it as code hangouts for now until something more specific jumps out at me. Where I'm from? I'm from Germany. But I haven't been there in a long time. So don't get much opportunity to practice anymore. Thanks for saying so. I'll check out your message on the channel. I don't know if I'll manage tonight. It's already really late here. But I'll definitely take a look tomorrow. Thanks for hanging out, guys. Take care. See you next time. Bye-bye.